group members, we have used mathematical techniques to give better insight into the current state of your storage business and also guide you into improving the overall success. For the next 10 minutes, we will be explaining the results of our work and the tools we've made to get there. We seek to assess performance and provide tested recommendations. The purpose of using mathematical modeling rather than other methods is that by bridging the real-world system to mathematics, it can yield more accurate and less risky results than other methods that aren't as data-driven. Analysis of data gives us insight into the business's strengths and weaknesses, while creating metrics provides a systematic and uniform way to measure for success. We can replicate observed trends and patterns in a mathematical model. Then, in the simulation, using the model we created, we can test changes targeting identified weaknesses to see its effects in a safe, risk-free environment. Outlined in our first report, where we focused on the company's current performance, we identified the company was doing well, however, there was still room for improvement. Occupancy rates were very high, with most units occupied. However, average length of stay was typically quite short. Downstairs units are also the most popular, with the highest occupancy rates. We also identified a potential seasonal trend which could be targeted to increase revenue.
Hello, my name is Joseph Bissets, and I'm going to present the mathematical models we use to describe the system. The data we were provided with for this project had many variables, which gave us broad scope for modelling. As a result, we modelled what we think are the three most important factors for the business separately. These factors are revenue, profit, and customer satisfaction. These were then amalgamated into a single model that gave us a business health score, which we believe accurately quantifies how a business is performing. We began with revenue. This model calculates monthly revenue based on the lease rate of occupied units. The main reason to consider revenue as a separate model was to see how much variation there was when looking at the different lease rates, as well as investigating the effect of incentives, such as discounts. Clearly, a business is interested in profit, so, using our revenue model and some basic cost assumptions, we created a model for profit. For simplification, we limited the costs of the business to staff costs and running costs. We assume these costs to be industry standard, and so we're able to find what we believe are accurate estimates. A good business in an area like self-storage, where there are many competitors, also relies on customer satisfaction. To make sure we had a way of quantifying this, we came up with a model that output a score between 0 and 1, where 0 is complete customer dissatisfaction and 1 is complete customer satisfaction. The outputs of these three models are then amalgamated into a single model to provide an overall indication of how the business is performing. We call this metric a business health score. It is measured on a scale of 0 to 100%, where 0% indicates no profit and complete customer dissatisfaction, while 100% indicates high profit and complete customer satisfaction. Having these three separate models, as well as the amalgamated model, allowed the simulation Ethan designed to run very smoothly.
In order to provide you with well-tested recommendations that we have confidence in, our team set out to build a simulation of the primary mechanisms behind your business. My name's Ethan. I worked on the simulation, and now I will be walking you through exactly how it functions. This simulation needed to be flexible, so we could run a wide variety of scenarios through it, fast, so we could run a large volume of scenarios through it, and detailed and visual in its reporting, so we could gain unique insight into your business's performance in these hypothetical scenarios. We believe that our simulation achieves these goals. Our simulation is very flexible. We can change the number, size, price, and average lease duration of each storage unit, and even add entirely new products. We can change the average number of daily customers to simulate varying demand, the proportions of the channels of inquiry to alter how customers contact your business, the success rates of these channels to simulate improvement to your customer service, the requested storage size of inquiries, the initial customer saturation, meaning how many of your units are full when the simulation begins, and the duration of the simulation. We can even simulate 100 years of operation. The first components in the system are the products. These are read from a product list spreadsheet that we can modify to change your business's units and lockers. Every distinct type of product has a name, length and width in meters, average lease duration in days, the total number of these units, and the remaining count, which starts off at the total. By default, these values were calculated from the original dataset. For each successful inquiry, we search our list of products to find the smallest unit that can fit the requested storage size and has at least one unit available. If we find a match, we create a lease starting on the current day, where the duration in days is drawn from an exponential distribution, whose average lease duration is specific to the product that we matched with. Every day of the simulation, a set of customer inquiries is generated, the number of which is drawn from a Poisson distribution, whose average is about 9 by default. Attached to each inquiry is a channel, so email, chat, walk-in, telephone, or online, that the inquiry arrives through, which is drawn from a multinomial distribution with the proportions of each channel. There's also a status, so either reserved or dead, which is drawn from a Bernoulli distribution of the specific channel's success rate, a requested length, which is drawn from an exponential distribution, and a requested width, drawn from a normal distribution. These were chosen as they were the best fitting distributions to these values in the original dataset. Shown now is an example execution of a simulation. We are testing the hypothetical scenario of removing all lockers, setting the initial customer saturation to 80%, and making more customers use the online channel for 2 years. We see that the simulation executes very quickly and prints a summary of its findings. We also get a PDF report generated for us, showing us how the business performed in this scenario.
Hello, I'm Robert Armour. Following on from my colleagues, I'll be briefly discussing some scenarios we consider to help improve the business. Following this, I'll be giving some recommendations.
Using the model discussed earlier, we have developed a series of scenarios to help generate new customers and increase profitability. We have developed short-term strategies which are low cost, low risk, and pose minimal disruption to day-to-day operation. Also, we have developed a long-term scenario which will generate significantly more customers and generate more profit, whilst aligning product offering with key customers. Short-term scenario 1 consisted of converting 85 of the 8.1 meter units into smaller units. The rationale for this is that the majority of customers are inquiring about smaller units. Also, customer inquiries for 8.1 meter units is relatively small. Further, typical move-in versus move-out rates indicate a net average annual move-out of 14 customers for 8.1 meter units. Short-term scenario 2 consisted of implementing a strategy to convert more email sales inquiries. The majority of sales inquiries come from email. However, it has a relatively low success rate. We have proposed implementing an email customer callback strategy to help develop customer relations and drive new business. It is predicted that calling email customers back will increase the success rate. Thus, this has been incorporated into our model for S2. Short-term scenario 3 involves implementing both S1 and S2 together. This table shows a summary of the outcome from the short-term scenarios. Modeling indicates an improvement on all metrics, particularly profit and revenue. The key benefits of short-term scenario 3 include increased annual revenue of almost $150,000 and increased annual profit of almost $150,000. Also, unit quantities are more aligned with customer inquiries. Other things to consider. These are very realistic strategies the business can implement. Also, whilst these are short-term options, based on the supply data, they will generate profit for years to come. In addition to the short-term scenario, we developed a long-term scenario. This consisted of converting the majority of the units larger than 9 minutes into smaller units, meaning the storage layout and unit sizes are better aligned with customer inquiries. As can be seen in the table, the long-term modelling scenario increased all metrics, particularly revenue increased significantly over the 6.5-year modelling period. The key benefits of our long-term strategy include an increased annual revenue of approximately $460,000. Also, this increased customer satisfaction. However, other things need to be considered. Firstly, a detailed investigation of costs would be required. Secondly, there's a potential to disrupt existing business. However, this could be minimised by implementing a staged approach. Here, this table is showing how the revised unit configurations helps align our product offerings with customer inquiries. Based on the above modelling, our recommendations are as follows. In the short term, the company should consider converting 80 of its 8.1 meter squared units into smaller units. Also, an email customer callback system should be implemented to help generate new customers. Looking long term, it is recommended that the business begin a cost and feasibility study for large-scale refurbishment of the site in alignment with the long-term scenario recommended above. On behalf of all my colleagues, I would like to thank everyone for listening to our report.